Hi, welcome to a very short session looking at the first part of question one of the mathematics question paper. We'll be trying out different kinds of questions as we go and trying to find a better way of thinking it through, rather. So here is one question paper. So starting off, obviously, we're just dealing with question ones only. And most of question ones are merely just algebra. Anyway, so let's start off with this first one. The first three questions given there are just solve for x questions, and solve for x questions are very easy. If you look at it, here. So looking at the first question, we're given this x minus 2 and 4 plus x, and this is said to be equal to 0. And now, given this, we're obviously supposed to find the value of x. Now, there's this wonderful thing in mathematics known as the zero factor law. The zero factor law says that when you've got factors, you have something that has been factorized completely on one side, and you have the value of 0 on the other side, you are allowed to split the factors and equate them to 0. And this is exactly what we have here. This has been factorized completely, and we have a 0 on the other side. So we're allowed to apply the zero factor law, which is to say that I'm going to take the x minus 2 and equate it to the 0. At the same time, I'm going to take the 4 plus x and equate it to 0 as well. And then I can solve for x individually. So this side x will be equal to 2, and this side x will be equal to negative 4. So this is obviously after performing a whole thing of transposing from one side to the other side and simplifying it like so. And there we go, we found our values of x, easy as pie. Second one is given 3x squared minus 2x is equal to 14. Now, while looking at this question, one thing we can learn is that when it comes to solving quadratic equations, this is a quadratic equation because we can see that we have to the power of 2 there. Okay, and one thing to note about the quadratic equation is that we need to have a 0 on the other side before we can perform any factorization or we can begin to apply the quadratic formula. We have to ensure that we actually have a 0 on the other side. So this 14 that we have here, we have to actually take it to the other side, giving us 3x squared minus 2x, and this is positive 14. When it gets to the other side, it becomes minus 14, and that leaves us 0 on the other side. Once we have this, you can try to factorize this, of course. However, it is best we apply the quadratic formula. I mean, they actually give us a clue that we're supposed to correct this to 2 decimal places, and there ain't no way that we can essentially try to factorize that. So when we apply the quadratic formula, it's essentially negative b plus minus the square root of b squared minus 4ac. This is all over 2a. Okay, and these are supposed to give you both your values x1. Okay, you're supposed to get your x1 and you're supposed to get your x2 all together. So you substitute it, and keep in mind to substitute with the value. So going to be negative 2. Okay, so for that b, you're actually going to have a negative from the formula and a negative from the 2, so it's actually a negative 2. And then you're going to try this twice, one with a plus and one with a minus. So I'm going to try it first with a plus. Okay, and square root of b, our value of b is negative 2. Okay, squared minus 4, and the value of a is 3, and the value of c is negative 14. So I'm just doing this with a calculator. The value of a is 3. Okay, and then if we put this into decimal points, we're going to get an x of 2,52. Or you do this the second time, very same substitution, however you're going to do it with a minus instead of a plus. So if you do that, you're going to get a negative. So our other value then is going to be that x is equal to negative 1,5, not 1,5, 1,85. Yes, 1,85 when we perform that substitution. Perfectly sound, perfectly fair. Okay, then let's look at number 3. Now on our number 3 there, it's also a solve. If you look at it, this one, it's not exactly quadratic by sight, but it actually is a quadratic in a way. Let me just write it down as it is, so we can really see what is really going on here. This is said to be equal to 20. Okay, what we can notice here is that we have exponential. It's an exponential solve, and with exponential solves, there's a whole lot of 2 to the x's here. So what we can attempt to do now is we can try to split this. Okay, so here, if we split this into a reversed exponential laws, so the 2 to the x is actually 2 to the x, actually 2 to the x. Okay, so we have 2 to the x, but this is multiplied by 2 squared. Because remember, the laws of exponents say if you multiply exponents with the same base, you add the exponents. That's pretty much what we have there. Okay, plus 2 to the x, and this is equal to 20. Okay, then I do have a lot of 2 to the x's there, so what we can attempt to do now is we can attempt to, let's replace 2 to the x with k. Perhaps that will enlighten things a little bit. So we have k multiplied by 2. Okay, we have 2 squared plus, let's call that k, and this is equal to 20. Okay, of course, before you write this, you have to show that you're saying let 2 to the x be equal to k. You have to show that part. Anyway, now that's done. Okay, I think we can factor out k, isn't it? So let's factor out k. We can take out k as a common factor. So that leaves us with 2 squared plus 1, and this is equal to 20. Okay, then let's simplify the inside of the bracket there. We simplify that part, so we do have k, and 2 squared is 4, and 4 plus 1 is 5. So I have 5 there, essentially, and this is equal to 20. Okay, perfectly fine. I divide both sides by 5, innit? And if you do this with a calculator, mentally 20 divided by 20 divided by 5, apologies, yes, 20 divided by 5 would be 4. So k is equal to 4. But remember, we said we're going to let 2 to the x be k. So let's bring back that 2 to the x. Okay, now I brought it back. It's now a much more direct solve. So let's try and write 4 with the base of 2. And 4 with the base of 2 would basically be 2 squared. Because 2 squared is 4. So 2 squared is kind of the same thing as what we have there. Okay. Then because we have the same bases on both sides, we can cancel them out. Like so. And then we can drop the exponents and say x is equal to 2. Okay. Perfectly so. Okay. Fair enough. That was an easy solve, yeah? Okay. Then we followed by a simultaneous equation on 1.2. Now, simultaneous equations are not exactly a big challenge. All you have to do is, well, substitute from one into the other, solve that other, and take it back to what you have initially. So, we're given 2 equations, one with a value of x, which is actually the subject, and the other one, nothing, is the subject. What we normally do is have 2 equations, then we would create a third equation whereby either x or y is the subject of the formula. Now, the wonderful thing about this question is that we don't need a third equation because we're actually given this first equation here, x was made the subject. So I'm going to substitute this equation into this equation. So this is how it would look like. So in place of x, I'm going to put 2y plus 3. I'm going to have 3. Instead of x there, I'm going to put that 2y plus 3. Fair enough. Not to forget the square, of course. Minus 5. Okay. And then again, it's x, but I'm not going to put in x. I'm going to put in 2y plus 3. Okay. And this is said to be equal to 24 plus 16y. Okay. And you can realize now that the only unknown variable here is y. Then what is to follow now is to, well, expand and simplify and solve for your y. So here, let's break out the brackets, right? By getting rid of that square outside there. And the only way to do that is by opening 2 brackets. So we're going to have a 2y plus 3 and another 2y plus 3. Okay, fair enough. There we go. Okay, not to forget the minus. Now I think it's fair enough that we can also expand this bracket directly. We're going to have minus 10. Yes, we're going to have, I believe that's a minus 10y Okay, when I have a minus 10y, negative and a negative should be a negative. Oh, negative and positive, that's a negative. So that's 5 multiplied by 3, that would be 5, 10, 15. So that's just that 15. Okay, now this might seem like it's a lot. Let's also transpose this side. Yeah, so we'll have a minus 24, right? Because I'm changing the sign. And a minus 16y, and this is all equal to 0. Okay, enough. Then let's expand this bracket that we have there. So 3y, 3. I'm going to put in a big square bracket because we're going to have quite a big expansion here. So 2y multiplied by 2y is going to be 4y squared. Okay, and the 2y multiplied by the 3 is going to be positive 6y. Okay, and then again 3y, and that would be another positive 6y. And then the 3 and the 3 would give me a positive 9. Then minus 10y minus 15 minus 24 minus 16y, and that gives us 0. Okay, and then we can simplify this part, so we'll actually have like a 12 on this part, right? And then let's also put in the 3 as well. So 4 multiplied by 3 would be 4, 8, 12. That's just 12y squared. Okay, and there we have a 12, and this 12 is being multiplied by the 3 coming from the outside, right? And 12 multiplied by 3 is, I believe that's 36. So positive 36y. Okay, and then 9 multiplied by that 3 from the outside would be 27. So we have a positive 27. Okay, and let's not forget minus 10y, minus 15, minus 24, minus 16y is equal to 0. Now let's expand this to the best way we can. The 12y does not have any like term. We don't see anything with the y squared here, so that's just gonna remain 12y squared. Okay. Now do we have anything with just a y? Absolutely. We have it there, we have it there, and we have it there. Let's simplify those. So 36 minus 10 minus 16 gives us 10. So that's a positive 10. So we're going to sorry about that. Positive 10y. Like so. Okay, now that's gone. Then we can do the constant 27, the negative 15, and negative 24. So 27 minus 15 minus 24 gives us negative 12. So this will be minus 12. And this is equal to 0. And then we can apply this into the quadratic formula, or you can attempt to factorize it however you'd like it. But for the sake of simplicity, I am going to put this into the quadratic formula, which said negative b, and the value of b here is 10, plus, I'm going to try it with a plus first, square root of, okay, and then we have a b squared minus 4, the value of a is 12, the value of c is negative 12, and then this is over 2, and the value of a is 12. Okay, and we get 2/3. Okay, or y will give you another value, which would be the negative, so we'll try it with a minus. This would be negative 3/2. Okay, this is what you get for the value of y. However, this is not complete. We have to find the values of x. And to get the values of x, we can put it back into another equation. I think we can use this equation then. Yes. So if we substitute this y value back into that equation, so we'd have 2 multiplied by y, which is essentially 2/3 in this context. So 2/3. I'm just gonna do this quickly with a calculator, and this will give us 13/2. So I'll get x is equals to 13/3. Or, and then the other one, I'll do it with, of course, the value of that negative 3/2. Okay, with that value I get an x of 0. X is then equal to 0. And then booyah, I have solved for x and y simultaneously. Sounds fair enough, isn't it? Let's try out the third one. For that third one, that 1.3 that we have there, what we're essentially doing there is solving a inequality. So we're given x minus 1 and x minus 2, and this is it. to be less than 6, and we have to solve for x for this. Now we're not finding the value of x, we are solving the inequality of x. So we do not expect you to say x is equals to unless you are finding critical points. Then you are permitted to say so. I'll show you what I mean. So let's propose and suppose that we are solving this the normal way that we know it. Obviously you would expand the brackets and take the 6 to the other side. Let's do that. If I'm expanding this, I'm going to have an x squared, which is x by x, and x by that negative 2 would be negative 2x, and that negative 1 and that x would be negative x, and that negative 1 and that 2 would be positive 2, and then we'll transpose the negative 6 and we'll say this is less than 0. Okay, then we can simplify this, of course. So the x squared doesn't simplify for obvious reasons. However, the negative 2 and the negative 1 would give us a negative 3x. And then 2 and the negative 6 and the 2, if you do this from the calculator or you do it from the top of your head, you should get a negative 4. And this is still said to be less than 0. Okay. When I get to this point, what I like doing is to say steady. I'm now finding the critical values. Okay. Now, I'm going to use the quadratic formula at this point. It's as if you're solving for x once again. Okay. So you can go in and say negative b, your value of b is negative 3, right? Plus the square root of b. Square root of b is still negative 3. Okay, and we'll put in a square. Minus 4, and the value of a is 1, and the value of c is negative 4 over 2, and the value of a is 1. Okay, and if you put this into your calculator, you should be able to get the value of the answer. Okay, let me do this. Okay. Right, just did it in the calculator now, and I got an x of 4. And remember, you're supposed to get 2 values. Did it the first time with a positive, the second time with a negative, I get a negative 1. Now note, I'm saying x is equals to because I said critical values. If you did not say that, you will be marked down for that, because you are solving for the value of x rather than the inequality of x. Now, let's just ask ourselves a little bit, okay? After we performed this whole expansion, this is kind of something that can help us understand what on earth is going on here. We're going to imagine this as a function, and this is a parabola if you can think about it. I mean, it's an x squared, that's a parabola. Okay, so this parabola will look something like this, isn't it? It's going to smile. How do I know it's going to smile? Because the x squared is positive there, so it's going to face towards the positive y-axis. Okay, then what I just found now were critical points, which are these two intervals here, which is essentially the negative 1 and the 4. But now, here the question was, where is it less than 0? Okay, where is all this less than 0? Where is the y of everything here less than 0? The y of 0 starts somewhere around there, isn't it? Okay, where is it less? Well, everything that's less than 0 is actually going down, isn't it? Because remember, that's where we have negatives, right? The where is the y? This represents y entirely, because that's, remember, f of x represents y. So think of this entire thing being y. Where is y less than 0 is basically the question. Where is y less than 0? Y is less than 0 here. Remember that those values on top there are greater than 0. Okay, now you can realize that the part that we're actually talking about is here. That's the part of the graph they are talking about. How do you explain that graph? We're going to say x, starting from this point here, x is actually greater than negative 1. Greater than negative 1. Okay, and still as well, x somehow also seems to be less than 4, if you see that, less than 4. So I'm actually describing this middle piece here. If the sign was different, and instead we're given a greater than sign, then clearly would be focusing on this part. So let me just redraw that same graph. If we were given a greater than sign, then we would be clearly talking about these parts of the graph, where y is greater than 0. But the only part that describes this are these parts of the graph, because we have to note that as the graph opens up, it gets more and more and more and opens up. Okay, so would be instead describing these parts if it was greater. However, they said it must be less than, so hence we're looking at the inside. Okay, hope that made a little bit of sense. Okay, following. Last question, we have that question 1.4. The question 1.4 is seems like an easy one. We're looking at the nature of roots. Yes. Okay, the roots of a quadratic equation are given as follows. So they are the roots of a quadratic equation. Fair enough. And we're supposed to find for which values of k are these roots real. When it came to nature of roots, you have to note that you're always going to work with the discriminant. Majority of the time, you're going to work with the discriminant. And the discriminant says b squared minus 4ac. This is what the discriminant is. Okay? Actually, the discriminant is not even given or denoted by d. It's actually denoted by the delta sign that we have there. That's what discriminant means. Okay. And you can notice that this discriminant looks familiar. It actually comes from the quadratic formula. So, in essence, it actually looks like this. That's the quadratic formula. And if we think about roots, the one thing that you should never do with a root, this is what I mean by a root, this thing that you have right here, that's a root. The one thing you're not allowed to throw in under a root is a negative value. So what we're saying is, if your discriminant was ever less than 0, then the values that you're going to get are unreal. Okay. However, if it was greater than 0, then perfect, you're going to get real roots. Note as well, there's a time where they're going to be equal to 0. This is where you're going to have roots that are real, but at the same time your roots are going to be equal. You're going to get the very same values of x. So this is a time where you can be solving for x and you'll end up with something that says x is equals to 2 or x is equals to 2. Okay, you're getting the very same values for your roots. Okay, and of course these people can combine them. They can say, how can you get roots that are real and that are both equal and unreal, for instance? Or rather, how can you get roots that are equal and real? So if you wanted to get roots that are equal and real, let's think about it. How do you get roots that are real? Well, greater than 0. Okay, how do you get those that are equal? Well, equal to 0. Then we'll combine them together. Kind of makes sense? Then if this is the case, you're going to be getting those that are equal and real roots. Okay, hope that makes sense. So in context, when we're looking at this representation on this question on number 4, what we're basically looking for is the discriminant. Okay, and the discriminant, as we said, is going to be b squared minus 4ac, or it's basically the whole thing under the square root. And if you look at it, the whole thing under the square root, or the discriminant in this question, is basically minus k minus 4. That's basically what's under the square root. So this is what we're going to work with. We need to put it in an inequality. How do we get roots that are real? Well, it must be greater than 0. So what I'm going to be saying is, I'm going to make an inequality whereby my roots or my discriminant is greater than 0. So I'm going to say negative k minus 4 must be greater than 0. And then I'm going to start solving for k in that inequality. I'm going to start off first, transposing that negative 4 to the other side. And I'll have my negative k. Say this is greater than. And obviously when it gets that side, when I have a positive. But then again, I'm supposed to find the values of k, not the values of negative k. So I need to solve for the positive k. So I'm going to divide both sides by negative 1. And when you divide both sides by a negative, your sign has to flip. So my sign will actually look like this. Less than. And then I'll have my negative 4. And voila, I have found the values. Perfect. I hope that made a whole lot of sense and sort of removed some skepticism in some of the questions. And of course, you can try out some of the other questions as well. If you have any questions, you can of course gladly ask. I will see you all in the next one.